Chapter 2 deals with the bonding of atoms and organic chemistry. Why study chemistry and atom physiology? Well, our body is made up of chemistry, food that we eat, medications, so we need to get a good understanding of. No matter. Matter is anything that takes up space, has mass. So matter is composed of elements. Elements, that means the different types of atoms. All solids, liquids, and gases are considered matter. And so elements are then again just the different types of the atoms. This table shows the major elements that make up our body, oxygen being the most. Know that atoms have these smaller pieces that make them up, so these smaller pieces are also called subatomic particles. Know that protons have a positive charge, neutrons have no charge, and electrons have a negative charge. And so we can look at the picture on the right side. The pluses that you see, those are the protons. The ones with the zeros are the neutrons. So both the protons and neutrons are located in the center part of the atom. The center part is also called the nucleus. So the electrons are much smaller and they're spinning around the nucleus. And so that's what the bottom part here says. Nucleus is the central part. We have the protons and neutrons, and electrons are moving around. No atomic number. This refers to the number of protons in the nucleus. And so each element has its own number. For example, hydrogen is 1. It never changes. It's always going to be 1. Therefore, it has 1 proton. So also know that the number of protons is equal to the number of electrons. So that means that hydrogen has 1 proton and it has 1 electron. Atomic weight then refers to the number of protons plus the number of neutrons. Each proton and neutron has a weight of 1 atomic mass unit. And so when you add these, you get the total atomic mass unit. Electrons still have some weight, but they contribute very little to the weight of the atom. But so atomic weight is when you add all the protons, neutrons, and electrons' weight. Mass number. This refers to just the protons plus neutrons, not the electrons at all. But again, the atomic weight is all 3. All right, isotopes. These are used in medicine, in chemistry. So we need to get a good understanding of isotopes. Isotopes are really just the variations of the same element. So the element is unchanged. It has the same atomic number. But what makes these different from each other is that these have different numbers of neutrons. For example, here they have listed oxygen. Oxygen's different isotopes. These little numbers refer to the mass number. So here, oxygen's atomic number, I know it's not written here, but it's 8. So it's got 8 protons. And so oxygen 16 has 8 protons and 8 neutrons. So oxygen 17, another isotope, so this has 1 more neutron. And oxygen 18 would have 1 more than that. So radioactive isotopes can be used in killing cancer cells. So here's an example. Iodine-131 can be used to destroy cancerous thyroid gland tissue. That's because the thyroid gland absorbs iodine to make its hormone. And so here it's absorbing this radioactive iodine. Well, so radioactive atoms can be damaging to our cells. And so here they're killing the cancer cells. Molecule means when 2 or more atoms combine. And so here at the bottom are some examples of molecules. H2, well, it's made up of more than 1 hydrogen. Or C6H12O6, glucose, well, that's a molecule as well. It's got more than 1 atom. Or H2O, that's a molecule of water. These are some pictures showing the molecules. Okay, so before we get into the bonding of atoms, why they get together, we need to talk about the electrons. So in that earlier picture, I showed how the electrons are spinning around the nucleus of the atom. Where they're located, where they're spinning, these are called electron shells or energy shells. And so here, these electron shells, energy shells, these circle the nucleus. Now, for the atoms that we're going to be concerned with, here are the rules. The first shell, meaning the first circle, can hold only up to 2 electrons. The second shell and the third shell, they can have up to 8. We'll do some examples of these. So first, here's a picture showing these different elements. Hydrogen only has 1 electron, therefore it only has 1 energy shell or electron shell. Helium has 2 electrons, but so look at lithium. Lithium has 3 electrons because its atomic number is 3 with 3 protons. And so here the first circle can only have 2 electrons, but so then the leftover one, the next one, then gets put into the next energy shell. On the exam, there will be a question in which you will have to answer what the valence number of an atom will be. So let's do an example here. Sodium, the symbol is Na. Sodium has an atomic number of 11. So then I will ask you, how many valence electrons will the atom have? Well, and of course, I'm giving you the atomic number. So you can do basic math to figure this out, but I think drawing it is much better. So I'm making this dark spot here, pretend like this is where the protons and neutrons are. But here we're concerned with the electrons. Drawing the first energy shell, first circle. So into this one, we can only fit 2. You can either make a dot or X's. Well, that's not enough. We need to get to 11. So we have to do another circle. Into the second circle, we can fit up to 8. So notice I filled the first one, so now I'm going to fill the next one. Now we're going to put the leftovers in the next energy shell. Putting the electrons together here, you don't have to. It just makes it easier to count. Okay, so I put 8 electrons in the second shell. So right now, we have a total of 10. But again, we're not done yet. We need to get to 11. You have to draw another circle, another electron energy shell. Put an electron anywhere on this third circle. Also, valence means the outermost. So here, in the outermost energy shell, there is only 1 electron for sodium. And so that's the answer to this question. Only 1 electron, 1 valence electron. Well, so the atoms are not stable if their outermost energy shell is not all the way full, it's not all the way complete. So what we're going to see is that sodium wants to give up this extra electron to an atom that needs it. I know you might be thinking, oh, can it just grab 7 more electrons to become 8? Well, the thing is that would be very hard to do. So I'll show you in the next part of the video that it's just going to end up giving it to an atom that needs it. So for example, chlorine.